right, y'all, X-Ray Ed is here once again for another episode of X-Ray Education. Today we're going to be doing something a little bit different. My students right now are in the Energized laboratory and they are setting up an experiment. We're going to be taking some images of a lateral ankle. And what we're going to do, we're going to take this, ow, dang it. Okay, watch out for that thing. It's hard and it's pretty unforgiving. All right, we don't want to bonk our head on that thing again. Okay, so what the students are going to do, they're going to take some images of an ankle. They're going to be using an ankle phantom, and they're going to be just taking some lateral pictures of the ankle. They're going to start out using 55 kVp and one mass, and then they're going to double their mass on each subsequent exposure. Now, we're going to wind up with I can't remember, something like 10 images of the ankle. Some of those things are going to be too dark. Some of those things are going to be burned out. Remember, we're using conventional film for this. Now, once those guys get done taking the pictures of the ankle on film, then we're going to do something a little bit different. We're going to do the exact same images, but except for this time, what we're going to be doing is using a CR cassette, but we're going to use the same technique. And so what we're going to do, come on in. What we're going to do is, and I've already set up the control panel there for you, so whenever everybody's out and you've got the door shut, you can go ahead and make your exposure. And you guys have got a label on there, right?
Yes, sir.
All right, cool. Sounds good.
Right there.
All right, first class image from the first class.
Oh.
Yeah.
Okay. We're going to do this on film, we're going to do it on CR, we're going to compare those things and see how it works out. Okay, so here we are, we've got our images done. So, okay, Miss Shelby, you were the master of the control panel. Tell me what, Shelby, sorry, Delaney. My bad. I forget who do you know who you're talking to? No.
All right, cut the camera.
Okay, so, yeah, cut, take two. Okay, so tell me a little bit about number one, which here is labeled A. What was the technique on that?
That was 55 kVp at 1 mass.
Okay, so a little light. It just doesn't look very good, does it? Okay, image number two, what was the technique on that one?
55 at 2.
Okay, so that was 2 mass. That's a little bit better. Oh, what about number 3?
3, we did 55 at 4.2 mass.
Okay, 55 and 4.2. What do y'all think about that image?
Good.
Number 3?
Number 3,
Yeah, I think that's probably our
trace. Okay, I tend to agree with Mr. Maurice. I think that number 3 is the best one of that first set of images that y'all produced. That looked pretty nice. Okay, let me see. All right, so number 4, what was the technique on number 4?
55 at 8.9.
Okay, 8.9 mass is probably a little much. We shouldn't have done that. And then 5 and 6, those things are burned out hard. What was the technique on 5 and 6?
5 was 55 at 15 mass, and then 6, we doubled that. It was 55 at 32.
Okay, not so good. Number 6 is burnt really bad. We probably can't even hotlight that. Okay, now it looks like number 7 was something completely different.
7 was 50, so we decreased the kVp 50 at 15 mass.
Okay, so that was 50 kVp and 15 mass. Okay, is that image looking good there or what?
No.
Yeah, I don't think it looks very nice. And we can't window width and level this puppy because it's a piece of film. Okay, what about number 8? What were we doing there?
8 was 55 kVp at 7.4 mass.
55 and 7.4. So that was kind of similar to what we did over there on number 4. Still too dark. It was dark before, it's still dark. 7.4 was a little bit of reduction in mass, but not enough to really help us. Okay, what about numbers 9 and 10?
9 was 63 kVp at 4.2 mass. And
Okay.
then 10 was 70 at 2 mass.
70 and 2. Okay, so really that 70 and 2 was actually the best of that set. Oh, wait a minute, we still got number 11 down there.
Correct.
Okay, what about number 11? What was the technique on that?
80 kVp at 1 mass.
80 kV in 1 mass. All right, so what do you guys think? Number 11, there it goes. Okay, number 11 or number 10? Or none of the above. Now, to give some direction to Ms. Michaela's clickery. All right, so if you wouldn't mind, tell us a little bit about image A. Okay, this is with the Fuji CR system. And, okay, image A, what was this? Bless you. What happened to Delaney? There she is. Okay, so this was the same technique that we shot before. This one, because with film, this thing was way too light. How does it look with a CR system?
Great.
It looks pretty good, doesn't it? This was 55 kV in 1 mass, right?
Yeah.
Okay, well, the CR system is more sensitive to radiation. Okay, over here is what it was with regular film. It looked like that. Okay, so that thing is just like completely worthless. But with the CR system, it looks pretty good. Okay, what was the S number? 373. Okay, is 373 a decent S number? It actually is. Okay, I've got a video that explains all about S numbers.
I need to watch that because they keep.
Yeah, it's only like 5 minutes long. Yeah.
Yeah, I'm gonna have to look that up. They keep every time we got the milk off. Yeah, that number's good. I'm like,
S number should be around 200 for everything, pretty much. 373, that means we were underexposed by a factor of not quite 2. Okay, so Ms. Michaela, take us to the next image. Okay, now this one has a good S number. This is an S number of 187. That means we're right on target with our S number. How does the image look? Passable?
yeah,
More than passable. It looks nice, doesn't it?
a bit copyright.
I'll take it. All right, what about the next image? Number 3. Okay, number 3, how's that image look? Objectively, just taking a look at this image. I think it looks good, doesn't it? It looks nice. Okay, what is the S number? 80. That means we were overexposed by more than 2. So this image looks good, but we overexposed the patient. So we probably shouldn't have done that. What was that technique?
55 at 4.2.
Wow.
That was
Okay.
the best one for the.
Yes, it was. Number 3 was our best effort over there on the film. With this, it looks good, but the system's telling me I'm a little overexposed, so
So the lower the S number, the more exposure?
yes. And you're going to see what happens as the exposure keeps going up. Ms. Michaela, take us to image number 4. Okay, image number 4. How's the picture look? Looks good. Would you pass that? I would pass that in a skinny minute. It looks totally fine. What is the S number?
41.
41. That means that we're about 5 times overexposed, right? So yeah, this is pretty hot, but the image looked good.
So I guess different from, so if we're looking at the film distance, we're just looking at the film itself and kind of gauging the distance.
Exactly.
If we're looking at CR here, we just pay attention to the S number.
With CR, you're going to be looking at your image and your S number. You're going to take both of those into account. And this is the reason why. Okay, with film, if we did this nonsense, it would be readily apparent for all to see. Because right over there is the equivalent image, number 4. How does that thing look? Well, it's dark. You know, as soon as that thing comes out of the processor, everybody's going to be like, what the heck did you do? You know, you shot this thing way too hot. Go back and do it over again. And all your coworkers are going to be making fun of you. But if somebody comes walking by your workstation and sees this, what are they likely to say? Good job, Ms. Emily, you keep doing what you're doing. Unless they happen to notice that S number, in which case that's going to get their attention. But the S number's not right in your face, is it? It's over there to the side where you have to go looking for it. All right, take a look at number 5. What does that look like? How do you like that image? That's gorgeous, man. That looks super nice. What is the S number?
23.
23. Okay, so we're nearly 10 times overexposed here, next image we're going to look at here, now we start varying the KVP. This one, what was the technique?
50 at 15.
50 and 15. Okay, so we lowered the KVP, we increased the mass, 50 and 15. Does the image look okay? Are we under-penetrated?
This one?
Yeah, number 7. Okay, take a look at that image. Study this image carefully. Okay, and then go back to number 11, just for comparison purposes. Okay, see even though the S numbers aren't all that different, so the exposure is not that far off, but you can definitely see a difference. Okay, so how did our experiment turn out? Were there any images on the CR that were just like totally not usable? They all pretty much worked, didn't they? It didn't matter what technique we used. The only thing we saw was some of our S numbers got out of control, but the images themselves look pretty nice. Even that joker right there. Okay, number 6, which on the film is burnt to a crisp. Where is it? Right there. Okay, number 6 on film was just burnt black. But with the CR system, looks fine. But we probably don't want to do this on, as a habit. This is the kind of thing where you take the image and you look at the S number and you're like, oops, shouldn't have done that. Okay, so what am I going to do on my oblique ankle x-ray? Say this is my first exposure and I just didn't pay attention to the control panel and it was still set for like an abdomen technique.
Turn the mask all over.
Yeah, I'm going to turn that mask way down on my next shot. But can I still pass this to the radiologist? Absolutely. Absolutely. Now, it is possible to completely fry an image so bad that even the CR can't fix it. A couple of supplemental images that I wanted to show everybody. These were produced by the afternoon lab group. Now, this image was shot at 1 mass and 40 kVp, and it demonstrates quantum model. If you take a look here, especially if you zoom in, like if you don't know if your image has got quantum model or not, just zoom it in a little bit, and if there's modeled there, then you'll be able to see it. And as you can see how this image is really fuzzy, that is quantum model. The other image that we shot was, this image was shot at 75 kVp and 100 mass. And as you can see, what we've done here, this whole area is burned out. This is an area of saturation. That's what pixel burnout looks like on an image. And typically it's not this blatant. I mean, this is just absolutely tragic. So you cannot window width and level this. Every pixel in this rectangle has been exposed to the point of saturation, and so the computer can't tell the difference. It doesn't know where one pixel stops and another pixel starts because they all look the same, and therefore no window width or level is possible. So this image, even look at this, even if we invert it, now the whole thing is just whited out. I mean, there's literally nothing there to look at. So yeah, you don't want to fry it, but you can, as we saw, we can shoot at 80 kVp in 1 mass. Do we still have decent contrast? Yeah, it's actually not bad. And we can window width and level. We can enhance the contrast if we want to. So you can definitely shoot ankle and tib fib and knee x-rays at high kVp and low mass with a CR system. And even though the contrast is affected, it's not completely ruined. So high kV, low mass techniques are absolutely possible. And it turns out that's actually better for the patient. So as we've seen from today's experiments, is it possible to shoot x-rays, extremity x-rays, using very high mass and come out with some really good looking images? Yeah, absolutely. We can shoot x-rays at 15, 20, 30 mass, no problem. But is that a good idea? No, it is not. And one of my students was asking, okay, what exactly do we mean? Because today's lab was entitled Dose Creep. What do we mean by dose creep? Well, dose creep is the tendency of every technologist, yours truly included, to bump up the mass anytime they think that, okay, well, maybe this limb is a little bit edematous, or maybe this patient's a little bit bigger, I'll just increase the mass. Next thing you know, you're increasing the mass for every patient. And so everybody's winding up getting way too much dose, but we're trying to avoid getting any quantum model. We don't want our image to be underexposed. So yeah, we just increase the technique because we know we can avoid quantum model that way, and we won't have to repeat our exposure. And provided the image isn't saturated, then it looks pretty good. It looks very good, as a matter of fact. So yeah, whenever you're making your x-rays, try to keep that mass to a minimum. The same technique you were using with film works with CR and DR, so keep it ALARA, as low as reasonably achievable. All right, thanks very much for tuning in once again. Don't forget to like and subscribe down below, and we'll see you here again for another exciting edition of X-Ray Education.